So you're asked to solve for the angle indicator, right? So you're asked to solve for angle A here. Now, if you're stuck with that, this is where you can use some of the resources I shared with you. So this one's finding an angle in the right angle triangle. And they give you, some diagram here, like you have length of a ladder and the distance between the foot of the ladder and the bottom of the wall, or bottom ladder to the wall. Oh, there's Ben. And you're trying to solve for x here, this angle. And first of all, they review opposite, adjacent, hypotenuse. So opposite the side, opposite the angle. Adjacent is right next to it, but adjacent's always got to be a flat side or a leg, not a hypotenuse. Hypotenuse is always the side opposite the right angle. It's always along the side. So in our case here, if you're trying to solve for x, the 2.5 is opposite, the 5 is the hypotenuse, because they said so. So ka toa. So which one uses opposite hypotenuse? Clearly sine. So you got to use sine. So they say that sine of the angle equals opposite side divided by the hypotenuse, which of course will work out to be in 0.5. Then to solve for x, they show you what to do. So that's how you do these kind of problems. So that's exactly what I'm going to do for this worksheet. Here I have theta, or angle A, because theta is located at angle A. 12 is clearly right next to angle A. And it's a leg. Remember, a leg is anything that forms a right angle. 13 is hypotenuse because it's directly opposite the right angle, right? It's opposite the right angle. So you're going to say cosine theta equals 12 over 13. That's it. Well, not that. That's it. There's more to do, but that's what you got to say, because you got to use the ka part, right? The a over h part. There's a so that's over h. There's a ka that's a over h, and there's a oa that's tangent, right? So we use a ka. So that's why I'm using cosine, and the adjacent is 12, the hypotenuse is 13. So theta will equal the inverse cosine, because that's how you move the cosine from right to left. Cosine is not a variable, just so you know. I've seen students do this in the past. And I've had seniors do this in pre-calculus, which I find incredibly frustrating because they saw this in geometry. They've talked about algebra and algebra 2, and they do this when they're 18 years old. And I get a little frustrated sometimes when they do that. They'll do something like this here because they think it's a variable. That is not a variable. Please don't do that. If you really want to get on my bad side, then do that. Don't get on my bad side. Don't do that. So, yeah. It's a function, right? So cosine's a function. It's some operator. In order to undo the operator, you got to do the inverse. It's kind of like if you have like x times 2 equals like 14. X is being multiplied to 2. How do you undo the multiplication? You divide, right? So it's no different. There's a way of undoing the cosine. It's the inverse. In fact, actually, division is the inverse of multiplication. We just haven't really mentioned it that way, but it is. It's the opposite. So that's what we're doing here. And then you got to use the calculator to work that out. The calculator will tell you what the answer is. And what you could do is you could use a graphing calculator if you got it. I'll pull up mine over here. Let's see here. Just realized I have my parents' water bill in a different folder. I don't know why that is. I'm going to have to move that. There we go. Actually, very grateful my water bill is not metered. In the Bay Area, it's a little different. Okay. So yeah, so you got to do inverse cosine. Second cosine. Second, it is not responding. What the heck is going on here? There we go. Second cosine 12 over 13. There you go. Oh, I'm in the wrong mode. I know it's weird. There we go. Now let me try it again. Yeah, 22.6 degrees. Not that hard. Pretty easy, right? And so you kind of just do that over and over again. My hope is that the drill and kill, the repetition, will help reinforce this topic. Because there's 7 more problems to do. I'll do one more. Like here's angle A. Clearly 4 is opposite angle A. Clearly 13 is adjacent. So it's going to be the TOA. So tangent theta is 4 over 13. Theta will be the inverse tan of 4 over 13. And then just use a calculator, right? Just use a calculator. Calculator's your best friend here. Second, inverse tan 4 over 13. Boom, boom, boom. And we're A-okay. We get 17.1 degrees. Yep, you see the answers right there. See, so you could do more of those if you got stuck and need more practice. But that's all you're doing. You're just identifying the sides at opposite, adjacent, or hypotenuse, using the right trig function. Remember, sines for opposite or hypotenuse, cosines for adjacent or hypotenuse, tangent for opposite or adjacent, so to, that's how we can remember it. And then you set the equation, then you solve by just moving this trig function to the other side by doing an inverse. And then the calculator works. You let the calculator do its magic. So let's look at another type of problem where you have to solve for a missing side. You're given an angle, you got to solve for a missing side. Same thing. Number 9, that's angle B. That's going to be adjacent because clearly 11 is right next to the angle. And x is hypotenuse because it's opposite the right angle. So you can use so cosine of 37 degrees equals adjacent, which is 11, over the hypotenuse, which is x. And again, if you need a resource, the resource is right here. This is to find a side. So again, they kind of review, what is sine, cosine, tangent, what's the opposite adjacent hypotenuse. And this case here, you have a tugboat, looks like, or a ship. It's anchored. The line that's connects the boat to the anchor is 30 meters long. The anchor makes 39 degrees with the ocean floor or bottom of the whatever body of water you got here. You want to solve for D, which is the depth of the boat above the water, or depth of the water, whatever, right? So you want to solve for D here. So it's pretty clear that the 30 is the hypotenuse, the D is the opposite. So you have an O and H situation, so you got to use sine. So the sine of 39 degrees equals opposite of the hypotenuse, or D over 30. Use your calculator, solve for D, and you got the answer, right? So it kind of explains again how to do it, and even explains in a summary. So you have this as a really good resource, and there's some really good examples here. So definitely use that as a resource if you're stuck with this. If you even need to use this on our test and you have a device with you, that's totally fine. Just make sure you're not communicating with somebody. I trust you guys don't do that. But yeah, so like, this case here, let me undo. So then you got to multiply both sides by x because you have to get x to the other side because x is a denominator. And then you got to divide both sides, whatever cosine 37 degrees is. I could actually work it out right now, use my calculator, or I could use the calculator on my computer screen, but I'll do the handheld. Yep, I got 0.7986. So x times 0.7986 equals 11. So x is 11 over 0.7986. So you get 13.7 or 13.8. So x is 13.8, and you can check the answer key. Yep, 13.8. Let's try it one more time. And then you have like others that you can do, again, a lot of drill and kill here. So here you got 32 degrees. X is clearly opposite of 32 degrees. 13 is clearly adjacent. So sine of 32 degrees equals x over 13. Great. Right? That's your tangent, my bad. I don't know what's wrong with me. Sorry guys. Okay, x over 13. It's OA. I should know that, right? That's opposite, that's adjacent. I'm going too fast. My apologies. So, toa. Tangent's opposite of adjacent, okay? So tangent 32 degrees x over 13. And then you multiply both sides by 13 to isolate x. And a tangent 32 degrees, use your calculator. Tangent 32 is 0.6249, I get 0.6249. Multiply it to 13, bingo, we get it 8.1. So it's 8.1. And it should be 8.1 because if that's 32, that's going to be 58 degrees. 13 is opposite 58 degrees. 13 is opposite a bigger angle. So x got to be less than 13, right? Because x is opposite of smaller angle, right? So that should make sense that we did this right. So always got to take a step back and make sure this physically makes sense. That the answers I'm getting are, the side is opposite a smaller angle or whatever, or bigger side is opposite a bigger angle. Make sure it makes sense. And then of course for these problems here, they want you to solve for the missing sides and angles. I'll do this one more time. So it's up to which side you want to solve for, but let's get the missing angle. That's easy. That's 28 degrees. That's easy. Let's get that out of the way quickly, right? Not that hard. We can handle that one. Now, this side is 22.6. 62 is clearly adjacent. That's clearly hypotenuse, right? Looks like a cone. So you're doing the it's up to you which one you want to solve for. First, you want to solve for the adjacent or hypotenuse. Doesn't really matter. Let's say you want to solve for the tangent. So you want to solve for the adjacent. Then you would say tangent of 62 degrees equals 22.6 over BC. Or you could use the 28 degrees, and you could, then 22.6 would be adjacent to 28 degrees. Could have done that, but since I'm focusing on 62 degrees, the 22.6 will be my opposite. The adjacent, of course, is BC. The hypotenuse, of course, is BA. So you're solving for BC here, so you got to multiply both sides by BC. So BC times whatever tangent 62 is, use a calculator. Tan 62 is going to be 1.8807. There's too many O's. There we go. Equals 22.6. BC is going to be 22.6 over 1.807. Okay, very nice. Yeah, and then you just punch, just do the math, right? I mean, do the calculator work. You get 12.02, which makes sense because opposite smaller angle, so it should be a shorter side compared to AC, or just 12, we could say. And then once you have that side, if you want to solve for the hypotenuse, you don't have to do trig anymore if you don't want to. You can now do Pythagorean theorem. Because now you got two legs of the right triangle, and that's going to equal c squared. And you solve for c. So I got to do that squared plus 22.6 squared, root the sucker. Hold on, I messed up. 12.02 squared plus 22.6 squared, root it. Yeah, I get 25.6. Or you could have done like another trig function if you wanted to. But that's how you solve those triangles. You gotta do some trig to get one of the sides, and then you can use Pythagorean theorem to get the other side. And then of course, getting the third angle there, just do 180 minus the sum of the other two angles, right? So again, you have drill and kill. And if you get to, obviously submit your work so you can get some credit for it. So any questions? Okay. If you do have questions, if you do have any individual questions that you may be more comfortable asking maybe during a break or at the end of the class. And my plans to end class about 12:45, 12:50 today. We are going to take a longer lunch break because I do need to step away from the class for a little while. So the plan is we will do a break around 10 o'clock. We'll probably do a 10-15 minute break. Then we'll do a long lunch break, 11:30 to about 12:30. And then we'll come back at 12:30 to kind of check in. And I'll give you guys some work you guys can do during lunch break if you like, just so you can get ahead a little bit. But yeah, okay, so hopefully that is a-okay with all the trig stuff. And again, you have these resources right here. You have these right here to help you out. Obviously, you got to use a calculator. Yeah, you have the video from yesterday. This video I'll upload as well. So the other video I posted it was from some other guy that I posted on Monday because I actually deleted the one I made. So you got lots of resources to help you out, and of course, ask questions. So that's kind of the story with trigonometry. Hopefully, it doesn't seem too bad. And let me go ahead and stop sharing for a sec. And let me just make sure I say Ben is here because Ben is here. Okay, so you are digital learning. And I guess we still don't see Sienna, do we? Okay, so she is not here. Okay. Cool. Let me close that down. Great. So now let's move on to 8.4, 8.5, and 8.6. So we got 3 more sections to talk about. I know a lot of material we got to cover. So let me close that down. And I had 8.4 and 8.5 and 8.6 open. I don't know why they're closed. Okay, let me open them up right now. Try it again. There we go. Okay. Go back to sharing my screen again. So our plan is to go over 8.4 first, and then there's a worksheet associated with it. So after I go over this and we do some practice problems, you guys will do 8.4. Then we'll do 8.5, do a worksheet there. Let's see where that takes us. Maybe we'll do a break somewhere in between there. But I do want to cover all 3 of these sections before our lunch break at 11:30. And then there's a chapter 8 test review that you probably could work on during the lunch break, which we'll check back on. I may actually have that open after lunch break. And that's where you guys can ask questions. Okay. So 8.4. Properties of a rhombus, rectangle, and square. All right. So let me do a little teaching first on a whiteboard. So you may want to annotate your notes or use a separate sheet of paper. Okay, so we talked about parallelograms yesterday, right? And let me define it for you guys. It's going to be a quadrilateral in which there are 2 pairs of sides that are congruent and parallel. Okay, there you go. That's the definition of parallelogram. And draw for you a diagram. A parallelogram could look like this, right? As long as, and let me label A, B, C, D. As long as you have 2 pairs of sides that are congruent and parallel. Okay. So the dash means they're congruent. The arrow means parallel. So therefore, AB is congruent to CD. Also, AB is parallel to CD. Okay. BC is congruent. Oh, there's Sienna. BC is congruent to AD. And BC is parallel to AD. So that's the definition of a parallelogram when that happens. Now, could a parallelogram look like this? Like a rectangle? Sure. Why not? As long as it satisfies that definition. Could it be a square where all the sides are the same and you have all right angles? Sure. That satisfies the definition of parallelogram. Could it be a rhombus? A rhombus is kind of like a diamond. All the sides are the same. Okay, that is not a good looking rhombus. I could do better than that. Okay, let's try again. Okay, I think I did it right there. So all the sides are the same, but you don't have right angles. That's a parallelogram also. That's also a parallelogram. And that's the 3 shapes we're talking about 8.4. rhombus, rectangle, and square. In fact, actually, let me delete that. Let me add a few more notes here. Rhombus is a special parallelogram. All sides are congruent, but not all angles. And it's all four sides, not all four angles. Okay, that's what a rhombus is. A rectangle is a special parallelogram. All four angles are congruent, but not all four sides. And by the way, when all four angles are congruent, they're going to be right angles because everything adds up to 360. Remember we talked about yesterday, n minus 2 times 180 is sum all interior angles. Four sides, 4 minus 2 is 2. 2 times 180 is 360. If you chop up 360 four ways equally, right, 360 divided by 4, you get 90, 90, 90, right? So that's a rectangle. And then lastly, a square. I need a little space here. A square is a very special, say, all four sides and all four angles are congruent. In fact, actually, a square is also a rectangle. Sorry, I take it back. Well, no, it is. Yeah, a square is a rectangle. It's a special rectangle. A square can also be considered a rhombus. It's a special rhombus because it not just has all four sides, but also the angles. And a rectangle is all four angles, but not necessarily all four sides. So actually, let me rephrase. Not necessarily, because a square could still be considered a rhombus. It's just a special, and a square could be considered a rectangle. It's just more special because all four sides are the same. So I should say not necessarily. Because a square does satisfy the definition of a rectangle, and a square does satisfy the definition of rhombus, and of course, a square satisfies the definition of parallelogram. So there's kind of a hierarchy here. Actually, I should have flipped it over, but the parallelogram is kind of like at the bottom of the food chain. The rhombus and rectangle are kind of in the middle, and the square is all at the top of the pyramid. Okay, questions before we do more of the notes and have you guys do a worksheet. Okay, let me go and clear this. Let me share, and let me actually update attendance also. Give me 1 second here. Give you guys a chance to kind of simmer over that material we just talked about. So here, just gonna make sure. Update attendance because now Stan is here. Save. Okay. So now let's share the screen. So now let's do the work. This right here. So first off, explain the error the student made. What error does the student make? DFG is a parallelogram. So you're going to have to move the 5 here and the 7 here. So opposite sides are congruent, not adjacent sides. Unless if all 4 sides are the same. Okay. Well, this is kind of fun. It says IQ test. If you could rearrange these letters, you would have the name of what? Anyone want to take a stab as what they think this would be? If you rearrange these letters?
Pacific.
It's an ocean, yeah, Pacific Ocean, right? There might be a city that's called Pacific something. I don't know. But anyway, Pacifica, there you go. Right? That's a city in the Bay Area, south of San Francisco. It's right next to the ocean. It gets very overcast in the summer. And also it's kind of far from a lot of other things. Okay, rhombus. So again, it's quadrilateral, it has 4 congruent sides. Rectangle, I talked about that, 4 congruent angles. A square is a special rhombus and rectangle. All 4 sides, all 4 angles are the same. So that's just a nice summary, but I wanted to do a little teaching first before I just glossed over this, right? So for any rhombus, QRST, the side where the statement is always or sometimes true, draw a sketch. So because they have it labeled in this order, in alphabetical order, that's exactly how I'm going to label the corners. Not the best looking rhombus, but we'll go with it, QRST. So Q and S are clearly opposite of each other. And it is a special parallelogram where all opposite angles in parallelogram are congruent. So this is always true. Where Q and R, sometimes true. If you so happen to have a square, because a square is a rhombus, that's just a special rhombus. If rhombus QRST is a square. So it's like it's getting a special designation, right? It's it's kind of this hierarchy. Like everyone starts off as a parallelogram, and then if a parallelogram gets all 4 sides the same, it would call it a rhombus. If it gets all 4 angles the same, it would call it a rectangle. Or if it gets both 4 sides and 4 angles, then it becomes a square. So it's just a special designation. So classify the special quadrilateral here. All you know is that all 4 sides are the same. That's a rhombus. Because all 4 sides congruent. Here, well, these have to equal each other because they're opposite of each other. So let's work that out, see what happens. I have a feeling it's gonna be 90, just the way it's drawn, but you can't go based off looks. It's not good enough. X equals 28, okay. So if X is 28, you have 3 times 28 plus 6, which is 90. Okay, and then this one also would be 90, that'd be 56 plus 34. So in this case, now you have 90-degree angles everywhere. But because you have different sides, I mean, you have the left and right sides are the same, the bottom top side are the same, but not all 4 sides are the same. So then we would say this is a rectangle. I'll just separate that. That was for this problem. So for this one right here, because all 4 angles are congruent. And Neil, go ahead, question.
for the, is that 56 plus 30?
That's 56 plus 34.
34, thank you.
Because you have a 34 right here.
Okay.
Yeah. So once I solve for x, because the opposite angles in a parallelogram are the same, and I know it's a parallelogram because I got two pairs of opposite sides that are congruent. So I know it's at the very least it's a parallelogram. So opposite angles are going to be the same, semi-equal to each other. See what we get. We got x is 28. When you plug 28 back in to each variable expression, you get 90 and 90. Therefore, you got a bunch of right angles. You got a rectangle at the very least. And remember, for a parallelogram, opposite sides have to be the same because you got these parallel sides, right? You got yourself these parallel sides where if I call, say, angle A and call this angle B, I know A plus B is going to have to 180 because those are same side interior angles. If I call this C, I know B plus C is also going to add up to 180. And so A is going to have to equal C to make that happen, to make that work. Those have to equal each other if these two equations are true, right? You could do like substitution if you wanted to. I mean, A would equal 180 minus B, C would equal 180 minus B. So of course, A equals C. So that's why we can deduce that opposite angles are the same in parallelograms. And of course, rhombuses, rectangles, squares are special parallelograms. So they're still going to follow that same, what's the right word to use? That same relationship, right? Okay. Gosh, this is a little hard to read. Let me trace that a little better. So here you got this interesting design here. So you have that. Here you got two pairs of sides that are congruent, but right angles. And here you got, those are the same. That's 40 degrees, by the way, right? That's not good. Let's do a different color. That's 40 degrees. I suspect that these would also be the same. So what do you think each of these would be? Going from left to right. You can type in the chat, going from left to right. Well, if all four sides and four angles are the same, yep, square, rectangle, rhombus. Got it. Good work, Anil. Good work, Nina. Yep. Square, rectangle, rhombus. Perfect. That's square. That's rectangle. And that's rhombus. And reason why we could say that's a rhombus, well, that's 40 degrees. But because you have the adjacent sides the same, you know it's going to be, we know it's going to be a parallelogram because these are the same. And then you have, that's 280. So it becomes 320. So this has to be 40. So because you have two pairs of opposite angles that are the same, it's going to be a parallelogram. And then because you have adjacent sides are the same, and you have opposite sides are the same, all four sides are the same. So therefore, it's a rhombus, right? Okay, let's keep moving. Theorems, this is just more definition. I mean, you'd have to prove them, but we're not doing proofs here. Again, it's just saying, hey, a parallelogram is rhombus if and only if its diagonals are perpendicular. So it's kind of giving you some more reasons why a rhombus might be a rhombus. If the diagonals are perpendicular, which would make sense because if you had this, these sides are the same, these sides are the same, these angles are the same, what is going to happen, and you have a diagonal here. So obviously these triangles are congruent by side angle side, but also I could have done something like this. These triangles are also going to be congruent by side angle side. And then if I do this, the diagonals do bisect each other in a parallelogram. You may have forgotten that. So it means that this is the same as this, and this is the same as this. And what's going to happen is that now you could say that this triangle and this triangle are congruent by side, side, side. So let me back up a little bit here. Let's draw this in green. Draw this in green. Let's do a little more straight. Yeah, these are the same, obviously. These are shared. And these are the same because they're bisected. So if I get a highlighter here, that triangle, and then let's do a different color highlighter, and that triangle, those are going to be the same by side, side, side. So that would then mean that these angles have to also be the same. And because they're a linear pair, they're both going to be right angles. Well, there you go. You got perpendicular. Okay. So that's why they're going to, be perpendicular. And then parallelograms are drawn if only if the diagonals bisect the pair of yeah, the angles are going to be bisected because these triangles are congruent. And it'll be a rectangle if the diagonals are actually the same. Yeah, because here, if you got yourself a rectangle, right? You got this right here. You know that's a right angle. And that's a right angle. That side same as that. That side is that. So obviously these are so yeah, I mean obviously you have that diagonal there, but then if you were to redraw it like this, you'd wind up getting, and actually you wind up getting a bunch of congruent sides here because the diagonals do bisect each other. And this is the same as this, the same as this. So you wind up getting two pairs of diagonals that bisect exactly the same way. So those are going to be congruent. So that's another thing, but you don't have to prove them. We're not going to do any proofs. This one here says sketch rectangle ABC. Let's everything that you know about it. I mean, yeah, I mean, obviously AD equals BC, that's congruent. AB congruent to DC. The parallel also, AD is parallel to BC. AB is parallel to DC. The diagonals bisect each other. They're all right angles. Same thing with a square, but all four sides are the same. All four angles are the same. So I think you guys get the point. So let's do some practice. We'll do this till about, see how long it takes. Let me pull up. So it'll be the next thing you should see in your packet. Also, you could download in Schoology. If you go to Schoology, go to chapter 8. If you do need to download it, it's right there. It's should be classwork 8.4. Yeah. So what we just did was the theorems and definitions. That's what we just did. So you'll work on this worksheet. I believe the odd answers should be displayed. Yep. So I'll put you guys in breakout rooms. So I'm gonna have you guys work through all this, even the evens. And I'll come into the breakout room, see how it's going. So we got, shoot, we lost somebody. I don't remember. Well, I'll create 5 rooms, 4 people, whoever comes back. So there'll be 4 people in each room, and I'll check with you guys, see how it's going. So we'll do this for about 12 to 15 minutes, and then we'll take a break. They'll return to 8.5 after that. So let me stop sharing. Let me pause recording. Let's go through these really quickly here. So you're asked to explain the mistake here. I don't know if 7x minus 4 equals 3x plus 14, because if it's a rectangle, then I don't know that because the diagonal does not bisect the angles. It does for a rhombus, but not for a rectangle. Square it would, and actually told it's a rectangle. There you go. Instead, you're going to say 7x minus 4 plus 3x plus 14 equals 90. And then solve for x. That's what you want to do. I believe the answer key would show that. Yep. And then solve for x. You get 9 if you solve for x correctly. Here, state what it is. If it's equiangular, at the very least, I know it's going to be a rectangle. Equiangular and equilateral, then it's a square. Opposite sides are congruent. At the very least, I know it's a parallelogram. Opposite sides are parallel, same thing. Actually, you could put the other ones also, because there's special cases of them. And same thing here, rectangle, rhombus, and square. Diagonals that are perpendicular, that's not true for a rectangle, but it is true for a rhombus and a square. Diagonals bisect each other, that's true for all of them. An equiangular, rectangle, and square, by the way. So I'm pretty sure, yeah, number 3 is just a square. 5 was all of them. And 7, well, obviously all of them also, if you're going to say parallelogram. So 7 should be all of them. All of them should be listed. So those are the answers if you need to jot those down. Okay. Let's keep moving. Then for this here, classify the special quadrilateral and find the values of x and y. Let's see here. So at the very least, you know it's a rhombus, and these have to equal each other. And x is going to be 76, because that's 104. And then obviously you have 208 for those added up. You have 152 left over. Got to split that, get 76. These equal each other. Y should be 4. This is a rectangle, because you know all 4 angles are the same. So those equal each other. And those equal each other. And you just solve those. That shouldn't be too hard. The answer key shown below. For 11, you have a parallelogram at the very least. These equal each other. And of course, these are the same. Okay. Here you have, looks like 2y equals 10. Those are the sides. So 2y equals 10. So y is 5. It's bisecting. And here you have alternate interior angles, because those are parallel. 5x equals 3x plus 18. 2x equals 18. X is 9. Okay. So questions? We have that. Okay, Neil, go ahead.
Could you go back to number 8, please?
Yeah. So number 8, these have to be this because it's a rhombus. Those have to be the same. So y is 4. And then x plus 104 equals 180. So x is 76. Okay.
Thanks.
No problem. All right, let's move on to, so let's do a break actually. It's 10:12 right now. So let's do, let's come back at 10:20. So we'll do a short 8-minute break. Let's come back at 10:20. And we'll definitely do 8.5, and I'll have to do a little teaching there, and there'll be a worksheet. And then I'll try to see if I can sneak in 8.6 also. Yeah, 8.5 is on trapezoids and kites. 8.6 is on kind of connecting everything that it looks like. But there's an extra worksheet on 8.5 also that we'll need to do, which is right here. So yeah, so we'll come back in 8 minutes. Okay, let me share my screen. Okay. So let's close with 8.4 stuff, so 8.5. Okay, so 8.5 is on 2 other shapes called trapezoids and kites. Obviously, you should know what a kite is, but we'll talk about the precise definition. I'll do a little lesson on that stuff, and then we'll go through all this stuff here. And then there'll be a worksheet you guys do in a breakout room again. Okay, so first up, there's just a warm up. Some of you guys should have done often in Algebra 1. It's a process called FOIL. It's an acronym. Stands for first, outside, or I'll say outer, inner, and last. So he's using multiply x with x. You get x squared. Multiply x with -7. You get -7x. Multiply 8 with x, you get 8x. And 8 with -7, you get -56. So it's x squared plus x minus 56. So here we're just multiplying 2 binomials. Some people like to do this also. They like to make a little box that helps. They'll put x and 8 here, x and -7 here. So x and x, that's x squared. Then x and -7 is -7x. X and 8 here to get 8x. And 8 and -7 get -56. The like terms are 8x and -7x. That combines x squared, and -56 are unlike anything else, so they just stay as they are. And you get the same thing. So that's what we may have to wind up doing down the road. Okay, just an algebra skill to review. So outer, so first combine x and x, outer combine x and -7, inner combine 8 and x, last combine 8 and -7. Or you could do a box like I did off to the right, which is not quite following the FOIL technique. Well, kind of. You combine the first terms x and x, And then the outer terms of 8 and -7. Sorry, x and -7. Then inner terms 8 and x, and then the last terms 8 and -7. This is IQ test. It's really just make sure you combine fractions. Fourth of a half of a fifth. That becomes 1/40th. You multiply all the denominators together. 240 is 5. Okay, that's all. This is just combining fractions. Questions on those two warm-ups? All right. So let's do a little teaching on or lessons on trapezoids and kites. And then we'll do these notes here. Let me go to a whiteboard. Okay. So this is what we call a trapezoid. It has just one pair of parallel sides. So that's the definition, just one pair of parallel sides, and it'd be these right here. Those are not necessarily going to be the same. And the other two sides here could be different also. Now, if they happen to be the same, then we say it's an isosceles trapezoid. But guaranteed, the top and bottom will be parallel. What that means is that, for example, if this were 80 degrees, and this would be 100 degrees. That's because you got parallel lines, right? And remember, safe side interior angles add up to 180. So that's what we have happening here. And if it's isosceles trapezoid, then this would also be 80, and this would be 100. So that's what's going on with the trapezoid. It's just one pair of parallel sides. That's it. Okay, give you guys a chance to copy that. Okay. Then a kite we call that a kite. Well, we shouldn't know how a kite looks. I mean, some kites could have different shapes, but that's kind of your traditional kite. In this case, we can have two pairs of congruent sides, but the adjacent sides are congruent. So in this case, AB and BC are the same. AD and CD are the same, not opposite sides. That would be a parallelogram. So it's the adjacent sides. So AB is congruent to BC, and AD is congruent to CD. The diagonals will bisect each other. And it'll be perpendicular. So if I drew this diagonal and drew that diagonal, they will cut each other in half, and this diagram's gonna get a little busy here. Well, actually, it just bisects that one, not BD. My apologies for saying it with. But definitely they'll be perpendicular. So the diagonals will bisect the shorter, or the short diagonals bisect. Let me rephrase that. Okay. So that's a kite. I'll give you guys a chance to jot that down. Okay. So we're going to clear that. Let's now go to my full screen. All right. So you have exactly one pair of parallel sides, as you see right there. Isosceles when the legs, we can actually call these the legs. Should have mentioned that. Are the same. So determine whether the quadrilateral is a trapezoid. If so, find the missing angles. So this case, yes. And yes. That's because you have parallel sides. And here, because these are the same, those are going to be parallel also. Because these add to 180 degrees. Okay. So when you're asked to find the missing angles, this would be 105 degrees. This would be 75 degrees. This will also be 75 degrees. Now remember, with isosceles, you're going to have the base angles being the same, and these always have to have the 180, right? Because they're same side interior angles, right? Same side interior angles. Add the 180. So it's an extension of what we've done when we did parallel lines in the previous unit. Then here, if that's 110, that's 70 right here. These have to have the 180 also, or everything else up to 360. You have 90, 90, 110, that's 290, so you have 70. Okay. So you guys try. So we'll need to figure out this angle, and this angle. Here we got to figure out this angle, and that angle. And remember, trapezoids isosceles if each pair of base angles is congruent. That's another way of thinking of it. And isosceles trapezoids also have congruent diagonals too, just so you know. But going to try these two problems right here. Give you guys a couple minutes and then we'll talk about it. Okay, hopefully you're getting this being 62 degrees. That's also 62 degrees, and this will be 118. This will be 70 degrees. That'll be 110. And it'll also be 110. Okay. Right, because opposite angles will be the same. Actually, I guess that's a parallelogram, the right diagram, because you have the opposite angles the same, and you have parallel sides. Yeah, that would be well, the fact that it's parallel, you know, K is 110 or M is 110 because the same side interior angles. Well, I guess K, and then you were told that J and O are the same, so those are 70. So yeah, that would make sense. Could probably pass as a kite, which we'll talk about in the, no, not quite. The mid-segment theorem for trapezoids. The mid-segment's just a segment that covers the midpoints of each of the legs. So these are the legs. They don't have to be the same, the legs, but what will happen is that the length is 1/2 the sum of the bases. So you can see this formula right here. MN's a mid-segment, and it's half the sum of A, B, and DC. So if I look at like the example down here, 8.5.2, I'll call this X. So X is going to be half of 12 plus 28. Or X is half of 40. So X is 20. Here, same thing. X will be half of 18 plus 10. Or half of 28. Which is 14. So again, very straightforward topic. A lot of it kind of comes back to similarity. We won't go through the proof for it, but the mid-segment is just simply half the sum of the two bases. And we call the top and bottom the bases. So you have base 1 and base 2. Okay, let's keep moving. So there's a quadrilateral that has two pairs of consecutive congruent sides. It's called a kite. The diagonals are perpendicular, as I mentioned. So AC is perpendicular to BD. And we have one pair of congruent angles, these right here. And that's because we wind up getting two congruent triangles if you draw diagonal BD. The BD is shared between both triangles, so by side, BCD is congruent to BAD. So BCD, triangle BCD, is congruent to triangle BAD. By side. Therefore, the opposite angles are going to be the same because these are congruent triangles. But B and D are not necessarily going to be the same. And another thing I mentioned earlier is that if I call this, like, say, E right here, CE will be congruent to AE. Okay. We want to find and measure that angle. So this is going to be let's change the colors. So yeah, I mean, what we do know is that, let's go with black. 124 and 80 add up to 204. So if you do 360 minus that, you should get 156. And you divide by 2, because it's split equally between angle D and this other angle here, which is that called F. So you get 78 degrees. That's 78 degrees, and that is also 78 degrees. Okay, we go and clear. Actually, let me undo that because you're still copying. Okay, let's now go through the worksheet. So here you're being asked which statement is not always true. You have to select one, 3 of these 4, or look at all these 4 of these statements. Mid-segment formula, so we'll work through that. Some stuff about kites, finding missing angles. And here they want you to find the length of the sides using Pythagorean Theorem. So I'll put you guys in a breakout room again. We'll do it for, shouldn't take too long. I guess we could do it for about 15 minutes. And then when we come back, we'll go over the answers and we'll talk about 8-6. Just kind of putting it all together. And that'll take us to close to 11:30, which is when we'll do a longer lunch break. And I'll ask you guys to kind of start working through chapter 8 test review. So let me put you guys in a breakout room. We'll do it for 15 minutes. Stop sharing. Let's pause record. So the base angles of isosceles trapezoid are congruent. That is true. That's always true. Remember, here's a isosceles trapezoid. These sides are the same. Those angles will be the same. The mid-segment trapezoid is parallel to the bases. That's always true as well. They'll always be parallel. That's why it's half. It's using the concept of similarity. The bases of trapezoid are parallel. That's always true as well. That's the definition of trapezoid. The legs are congruent. Not always true. It could be, but not all the time. So D is the only one that's not always true, but A, B, C are always true. Then for 2, again, very simple. X is half of 21 plus 25. So that's 23. Here, X is half of 57 plus 76. What's 57 plus 76? I think that's 133. I don't know. 133. So that's 66.5. Okay. And then kind of do the same here, but in this case, you're going to say 7 is half of 10 plus 2x. So remember, you're making a relationship here, where 12.5 is half of 3x plus 1 plus 15. And you solve for x in each case. You can say 14 equals 10 plus 2x, so x will be 2 in this case. Or here, you can say 25 equals 3x plus 16, x will be 9, if you work that out. Let you guys copy that down and simmer over it just a little bit. Okay. Yeah, Anil, go ahead.
Is that 25 equals 3x plus 16?
Yes, that is. Yes. Yes.
Thank you.
Yeah, let's make it a little more clear. Yep. Yeah, because I multiply both sides by 2 to get 25. Okay. And then some more for the kite. Find angle G. Those are going to be the same. E and G. Angle E equals angle G. That's how kites are supposed to work. You got 140 already for the other two angles. Take difference to get 220. Divide that by 2. You should get 110. So angle G is 110 for number 6. Here, that's going to be 110. So that's 220. That's 280 right now. That's what it adds up to. So that'll be 100 degrees. Wait, is that right? No. 80 degrees. I should know better. 80 degrees. So question about 6 or 7. Okay, let's keep moving. That's 150, that's 90, so that's 240. So you got 120 left over, so each of these are 60. Okay, that's 120. So that adds up to 290. So that's gonna be 70 degrees right there. So that's for angle A. Okay, give you guys a chance to simmer over that just a little bit. Okay. And lastly here, you asked to find the side lengths. So if you do Pythagorean theorem, we'll call this like C. 6 squared plus 12 squared equals C squared. 36 plus 144, that's 180. So C is root 180. That will then be, you can simplify that. 36 and 5, I think. So you get 6 root 5. Again, you could do a prime factor tree if you simplified it. 10 and 18. 2 and 5. 2 and 9. 3 and 3. So 2 and 3, and another 2, another 3. That's how you get 36. And 36 is a perfect square. So that's 6 root 5. That's also 6 root 5. And then you can do Pythagorean theorem again. Let's say we call this like, I don't know, x. So you got 4 squared plus 6 squared equals x squared. So 16 plus 36, 52 equals x squared. X is root 52. 4 is a factor of 52, so you can say it's 2 root 13. Because 52, if you break that down, you get 2 and 26, 2 and 13. So yeah, that's 4 times 13, which is 2 root 13. So those are your missing sides. This said you round nearest 10th. I did as radicals. You could punch in a calculator and get the decimal if you want. But yeah, that's going to be 2 root 13. for those two sides. So that's just Pythagorean theorem, because we know that the diagonals are perpendicular, so we can use Pythagorean theorem in that regard. Okay, so we're going to do a lunch break around 11:30, and it's going to be an hour-long lunch break. Probably during lunch break, I'm going to ask you guys to work through the Chapter 8 test review, but we could also just go over parts of it anyway. And this will be homework, so I'll do it kind of like one from each topic, like the Chapter 7 test review. And we do have another test tomorrow. I don't have a practice test ready yet. I'll try to get one ready during the lunch break, and I'll share with you guys. I could try to dig one up, but obviously it's on quadrilaterals, and the Chapter 7 stuff was on trigonometry. So that's what the stuff's on, but I'll try to find some. Actually, you know, the textbook stuff should help. I'll point you guys to that. That's what I probably suggest for extra practice. The online textbook that or the PDF version, but I'll try to print certain portion and scan it so you don't have to like look at the whole file. I think that's what I would suggest you guys do. And it's gonna be like our other tests. It'll be paper, some multiple choice, stuff like that. And we'll do a review tomorrow morning as well. Anyway, so let's move on to 8.6. So putting it all together. Let me close these down. Okay, so 8.6, putting it all together. So here, this is a trapezoid. If that's 115, this is going to be 65, because the same side interiors have to add to 180, and since these are the same, that's also 65. And of course, this would be 115 right here. That's when you have an isosceles trapezoid. If loops are razies and razies are lazies, then all loops are definitely, I don't know. I don't want to deal with that right now. So number one, warm up. Hopefully that makes sense. So here's a hierarchy. So quadrilateral is kind of like, you know, kind of the base, right? And kites and trapezoids are very special ones. A trapezoid could be an isosceles trapezoid, but then a parallelogram could lead to more things. It could be a rhombus or a rectangle if all the sides are the same as a rhombus, all the angles are the same as a rectangle. And a rhombus or a rectangle could become a square if all sides and all angles are the same. So all squares are parallelograms, all squares are rhombuses, all squares are rectangles, but all rectangles are not squares. All rhombuses are not squares. All parallelograms are not rhombuses, rectangles, or squares. So again, a square, all squares are rectangles, all squares are rhombuses, all squares are parallelograms, not the other way around. So look at the arrows there, that helps. So quadrilateral ABCD has at least one pair of congruent opposite angles. What type of quadrilaterals meet this condition? So there's at least one pair of congruent opposite angles. So opposite angles are congruent. So it's definitely going to be a parallelogram or a kite. I don't know for sure if it's a rectangle yet, but I don't know much more than that. But it could definitely be a kite or a parallelogram. It says at least one pair of congruent angles. Parallelogram obviously have to have two. Kite, you just need one. And actually, kite's exactly one. But you don't know if it's a rhombus because you need all the sides to be the same, right? And you don't know if it's a rectangle because you need all the angles to be the same. And they have to be right angles. Okay, what was the most specific name for each quadrilateral? So here the diagonals bisect each other. So if you kind of look back over here, well, they don't kind of show that, but we don't know if it's, you know, if these are perpendicular. It sure looks like they are, but we don't know that. All we know is the diagonals bisect. So I'm going to call that a parallelogram. Here for a third one, I know it's a kite because you have consecutive sides that are the same. Here, because all the diagonals bisect, but they're all the same also. WY equals ZX. So that's going to be a rectangle. I can't say it's a square because I don't know if all the sides are the same. But when the diagonals are congruent, that's going to be a rectangle. Definitely not a rhombus because the diagonals are not the same in a rhombus. And it's more than a parallelogram. And also, again, you have one marking, one marking, one marking, one marking. So WX has to equal ZX, or has to be congruent. Here, yeah, that's just a trapezoid. Because you have one pair of parallel sides. Okay. There's enough information that the quadrilateral PQRS is an isosceles trapezoid. We have 74 and 74, that's 148. So then you have, and also 106. That's going to be 254. So that's also 106 to get to 360. So the answer is yes. And that's because same side interior angles, add the 180. And also base angles are congruent. Okay, let's guys kind of simmer over that. Okay. So then let's look at the table down below. So now we discuss every shape. Put an X in the box if the shape always has a given property. So this is parallelogram, by the way. So let me do it for a parallelogram, then let you guys try the other ones. So are all the sides congruent? No. Are both pairs of opposites congruent? Yes, I'll put an X. Are both pairs of opposites parallel? Yes, put an X. Exactly one pair? Nope. All angles congruent? Nope. Exactly one pair of opposite? Nope. Diagonals are perpendicular? Nope. Diagonals are congruent? Nope. Diagonals bisect each other? Yes, they do. So if I draw a parallelogram again, you definitely have these sides as being congruent. You definitely have these sides as being parallel. Yep. And if I drew this, you're going to definitely have this the same as this, and this the same as this. So diagonals do bisect each other. But they're not perpendicular. They're not the same because one diagonal is bigger than the other. Again, you don't have exactly one pair of opposite angles. You have two pairs of opposite angles are the same, but not exactly one pair of opposite angles are the same. All angles are not congruent. And again, you don't have exactly one pair of opposite sides that are parallel. So now I'm going to have you guys try rectangle, rhombus, square, kite, trapezoid. Put the x's in the right place where you think they should be. I'll give you guys a few minutes to think about that. Ask questions. I'll pause the recording. Yeah. Okay, now we're recording. Okay, so parallelogram. Remember, for a parallelogram, definitely both pairs of opposite sides are congruent and both opposite sides are parallel. And the diagonals do bisect each other. That's true for parallelograms. Now, all sides are congruent. That's only true for a rhombus and a square. Remember, anything that's true for parallelograms is also true for rectangles, rhombuses, and squares. They're special parallelograms. If you have exactly one pair of opposite sides are parallel, that's going to be a trapezoid. Exactly one pair of opposite angles are congruent, that's going to be a kite. All angles are congruent, that's a rectangle and a square. Whatever's true for rectangles is also true for a square, because squares are rectangles. And the diagonals being congruent, that's also true for rectangle and a square. And then this row diagonals are perpendicular. That's true for a rhombus, whereas true for a rhombus is also true for a square. And that's also true for a kite. And then there was some other things I kind of mentioned, that these two here would only be true for an isosceles trapezoid. And then that was bisected to show only one diagonal is bisected for a kite. Okay. So that's that. So sorry I didn't record it. Now that's recorded. Any questions on this table? Nope. Okay. Let me go ahead and clear. Now let's talk about the chapter 8 test review. So there's 6 sections we covered. Today we did properties of rhombuses, rectangles, and squares. We did properties of trapezoids and kites. We put it all together in 8.6. Yesterday we talked about finding angle measures on a polygon. The big formula was this: n minus 2 times 180. That's what we talked about in 8.1. 8.2 we talked about parallelograms, and we went more deeper with parallelograms in 8.3. Okay, so for this here, you said match the figure with the most specific name. Yeah, and all the answers are here, obviously. So if you have all 4 sides are the same, and 2 pairs of parallel sides, but we don't know anything about the angles, so I'm going to say a rhombus. Here, all the sides and angles are the same. That's a square. Here, only have parallel, but you don't know anything else. That's a parallelogram. It's the best I can say about that. Nina, go ahead.
Is this worksheet in the packet?
Yep, should be there. I think I put it there. Hopefully I did. Let me know if you guys don't see it there. Okay. Let's keep moving. For 7, I said I'll do one from each topic. The sum of the measures of the interior angles of a convex polygon is 3960, classified by the number of sides. So you just do this. And solve for n. Well, Ellie, go ahead.
I don't see it in the packet.
Okay, so what I'll do is I'll upload it to shoot, I must have not put it there then. Darn. You know what then? I'll upload it to Schoology and you guys can just work on it. I mean, if you could print it, if you have access to print it, great. If you don't, you could just do it on a piece of paper and work from a computer screen. Okay, so but I mean, I always do upload anyway, but yeah, thank you for letting me know that. So I guess I didn't photocopy it. That's unfortunate. So you have 3960 divided by 180. If you work that out, that would be 22. So n's gonna be 24. So you have 24 sides. And then if you want to find the measure of each interior angle, you simply do 3960 divided by 24. So each angle is 165 degrees. But remember, n minus 2 equal 22, right? That's why n was 24. Okay. So you'll do 8, 9, 10 on your own, and 11. It will talk about in class tomorrow. So again, that's number 7. For number 12, I'll just do 12 and have you guys do 13 through 17 on your own. Find the value of each variable in the parallelogram. So remember, they bisect each other. So 10 equals m. Also, n minus 3 equals 8. So n's 11. Because those are going to be the same as well. Okay, that's number 12. Okay, hopefully we're okay with that one. For this one here, more of the same thing. These bisect each other. Solve for x, x is 5. For 20, classify and find x and y. So do you have diagonals that are perpendicular, and you do have 2 pairs of parallel sides? That will definitely be a rhombus when that happens. So y is going to be 21 degrees as well because it does bisect the angles. If that's 21 and that's a right angle, that's 69. So x is going to be 69 degrees as well. And again, I know it's a rhombus because the diagonals are perpendicular. That's not true for rectangles, but it's true for rhombuses and squares, of course. But I know it's not a square because I didn't know if all the sides were the same. So that's that one. Okay, so you'll try 21 on your own, and 22, and of course 19 for 8.3 problems. This one here, we look at 23 on trapezoids and kites. You do have a trapezoid here. Angle F is 79 degrees. And it's isosceles. So if that is 79 degrees, angle G will be 79 degrees also. So that's 79 over here. That's going to be 101 then. And it'll also be 101. Okay. So I'll have you work out 24. And then finally for 25, let me move this. Yeah, for this one here, give the most specific name. I don't know if it's a square. You need this. But if all the sides are the same, I know it's not a rectangle, but definitely could be a rhombus. And that's because all sides are congruent. So that's 25. Okay. So that covers just a little bit of the chapter test review. Yeah, sorry that I don't have a hard copy of it. I thought I put a copy. I apparently did not. So I'll post it to Schoology. Actually, let me just do it now so I don't forget. So it's there because some of you guys might want to work on this. So geez, I thought you guys had a chance to work on it. Didn't put it there. It is here, chapter 8 test review. It is there, obviously, but I didn't photocopy it. So let's do this. We'll make it a homework assignment. Actually, let me photocopy. Let me paste this one here. Call it homework 12. Let me clear my screen. Maybe I'll do tomorrow. Yep, tomorrow, today's the 13th, tomorrow's the 14th. Make sure the file's there, which it is. Okay, great. And then for extra practice you guys can do, I'm gonna see if I can create a quick PDF. It might be a little tricky because when I'm on Zoom, it acts a bit slow. And I'm not sure which page numbers to go to exactly. Okay, it's a little too far, obviously. So yeah, it looks like they deal with the geometric mean stuff. No, we didn't do vectors. You didn't do log sines, log cosines. You did trig, solving right triangles. So definitely this is good. Yeah, this is good. Okay. And then I think then maybe it would be chapter 7 stuff. No, because we did chapter 6 when we did similarity. Yeah. Chapter 7 was mainly on Pythagorean Theorem trig. So I guess it'll probably be chapter 9 then. Let's see here. That's trig. Okay, then the trapezoid and kite stuff. Let's see, 7:30. No, we didn't deal with circles. Triangles, quadrilaterals. Yes, that would be good. Didn't do composite figures. Didn't do permanent area. Yeah, it looks like that's all covered in 9-1. That's interesting. Did it all. Okay. Well, anyway, I'll make sure. I'll suggest some stuff later today that you guys can do. But at the very least, work on the chapter 8 test review stuff, and I'll put some more stuff in the next hour. By 2 o'clock, I should have more stuff. I'll put it in under test resources, and I'll see if I can find a practice test also for you guys. And then we'll go over all that stuff tomorrow in class. Tomorrow we will be in person. 9 o'clock we'll meet, and we'll review for about an hour. Then we'll have a test around 10:15. It'll be a paper test and be done around 11:30 or so. So yeah, I think we're all set. If you do want to stay behind, I could tackle. I know a couple of you guys wanted to ask some questions, so I'm definitely free to do that. Otherwise, you guys are free to go. Enjoy the rest of the day. And yeah, we're almost done with this class. 2 weeks away.
We have
Thank you.
to